All right, so our last section, as you know, is trig graphs. And there's some things to help you at the top of the page here. But before I go through them, what I think will be easier is if I go through the basic trig graph of each one first, and then I start telling you how to move them around. I just want to make sure that you remember the original graph. Okay, so starting with the sine graph, I've just drawn these little tiny Cartesian planes, trying to squeeze them in there. When we did them in year 10, we did them in degrees. Then we introduced radians. So you can see I've marked on here very small, sorry about that. Pi and 2 pi, that's your 180 and 360. I could do the in-between ones as well, but not a lot of space there. So I've just done those two things there. For the sine graph, it starts at the origin and it will go up to 1, down to the pi, then down to -1 and back to 2 pi. And there is the y equals sine x curve. Okay, the cos curve is very similar. Same scale on my axes there, but it starts at the 1 and comes down to 0, then down to -1, back to 0, and up to +1 again. So the sine graph and the cos graph are the same graph with a 90 degrees or pi over 2 phase difference, we call that. It means that we move the sine graph pi over 2, because that scale there will be pi over 2. If I move it pi over 2 to the left, I would get the cos graph. Okay, the tan graph is different to the others. You have asymptotes at pi over 2 and -pi over 2. And just to show one repetition of the graph would look like that. Okay, so today we are going to be moving these graphs around, and we're going to be changing the amplitude, the period, as well as moving them left, right, up and down. Okay, and hopefully not too many of them all at once. We'll start with one thing at a time. So this little table goes through how to find all of the changes. If you have got a y equals a sine bracket bx plus capital C in brackets plus a d on the end. The capital A out the front of your trig function is going to change the amplitude. It's going to change the height of your graph. So if I was to change this to a 2, it means that my sine graph here is now going to have an amplitude of 2. Everything else, these zeros here, would all stay the same. It'll just be twice as steep. The period of a normal sine graph is 2 pi. That's how long it takes to do one rotation. We could keep drawing a second or a third, or we could even go backwards this way if we wanted to. So 2 pi is the original period of the graph. If I put a number in front of my x, that is going to change the period. And to calculate the new period, you divide your 2 pi by whatever that number is. So again, if that number was a 2, I would do 2 pi divided by 2, which makes pi. And that then means my whole graph is going to be squished horizontally so that a whole rotation is going to happen between 0 and pi. Okay? All right, so that's the A and the B that we've talked about. Now for the D. The D on the end, like with any graph, is going to move the whole trig function up or down. Okay, so if I put a +1 on the end of it, it means that my whole graph is going to move up 1. You just physically translate each point up 1 spot. And that leaves the fun part, which is where you move these graphs sideways. This is often, I think, the trickiest part, because you've got to readjust often your scale down here on your x-axis, depending on how far you're moving it. Now, there is a formula there, if you like. To find out how far you are moving your graph, you take the C and you divide it by the B. And it says that if it's a positive number, you're going to move it to the left, and if it's a negative number, you're going to move it to the right. And it says the same thing for the cos graph and the tan graph. I don't know about you, that I find that's tricky to remember if you're going to write it like a formula like that. Instead, for me, and you might like the formulas, that's fine, but for me, instead, if I'm given a question like this, I'll make one up here. If I had y equals, I'm not worrying about the amplitude or anything else right now, but 2x plus pi, say. I'm just going to be moving it sideways, okay? What I do is I take whatever is in that bracket and I make it equal to 0. Okay, remember doing that with some of our other graphs. So we'll go the 2x plus pi is equal to 0. And I want to get the x by itself. So 2x equals negative pi, and I divide by the 2, which means negative pi over 2. If when you do that, you get a negative, like I've done there, negative pi over 2, it means I want to move my graph pi over 2 spaces to the left, to the negative side. Okay? If I get a positive number when I do that, I want to move it to the right. You're concerned? No? Rose was shaking her head at me like I said something weird. No? You're good. I thought you were going, oh, something's wrong here. Okay, so does that make sense? Okay. The cos graph, I won't go through them in as much detail again. The cos graph is very similar. The A at the front changes the amplitude. The period for the cos graph is 2 pi again, so you divide it by b if you need to change the period, and the number on the end will move it up and down, just like the cos and and finding the horizontal translation the same way as well. Tan, the only different, well, a couple of differences. First of all, tan doesn't have an amplitude because it goes up to infinity and down to negative infinity. So even when you put a number in front here, all that really does is make it steeper, but it's still going to infinity and down to minus infinity. Okay, so you often can't see with the sketches that we draw, you can't really see the change of steepness very much unless you put an extra point on there. The period of the tan graph is only pi. Okay, so it's going to be pi divided by the b if we're going to be changing the period of the tan graph. And then moving it left to right the same. Okay, so with those rules in mind, let's do a few sketches. We won't do too many things at once. Let's start with number 1. It says find the amplitude and the period for the following. Sketch one period of the graph showing the intercepts and the turning points and asymptotes where there are some. Okay, so y equals 4 sine 2x. The 4 out to the front is the amplitude. Okay, so let's write that down. My amplitude is going to change to be 4 for this graph. The period of this graph, normally the period for a sine graph is 2 pi. So I'm going to divide that by the number that is in front of the x here, which is a 2. 2 pi divided by 2, the 2's will cancel out, and the period of this graph is going to be pi. Okay, it is helpful if you either know this really well, the original one, or you can draw a quick sketch of it each time before you do the new one. Okay, so my new graph. I haven't translated it anywhere. All I've done is change the amplitude and the period. So the sine graph starts at 0. Normally we have pi and 2 pi here, but we're going to be squishing our graph down so that I have a complete rotation by pi. So it's going to end there. It's going to go all the way around and do its thing and end at the pi. That means in the middle, that's going to be where it turns around from the top part down to the bottom. And in between those, it will be at positive 1 up here and at negative 1 in that part in there. Okay, so I'm just squishing it horizontally like that. And I only need to show the one rotation. I don't need to go to 2 pi.
Isn't it off?
Oh, thank you. Yes, sorry. I changed the period and I didn't. Yeah, you are correct. Thank you. I had to change my amplitude to a 4. I was focused. It was a rookie mistake. Okay, so you can show extra numbers on your horizontal scale. So there should be a pi over 4 in here. That would then be 3 pi over 4 in that one, just to show the 4 main points. So you can actually see this turning point here would be at pi over 4, 4, and the other one, 3 pi over 4, negative 4. All right, ready for the next one? Okay, so far? Good. We're doing a tan graph next, and we have a number at the front again, which means we think we should be changing the amplitude, but it's a tan graph, which means we're not really doing anything. So amplitude, we can just put NA. We can't really see a change in the amplitude, not applicable for a tan graph. The period of the tan graph is normally pi. I need to divide that by the number in front of the x, which is a third. When you turn that third upside down, that will become 3 pi. So we're actually stretching this graph to make it wider. So 3 pi, we need to draw that on our, let me put that in the middle. For tan, we want our y-axis in the middle because we know we have those asymptotes on either side. Now thinking back, let's have a little quick squeeze back here for a second. That was my period of pi here. Okay, I had half of it on that side, half of it on that side. So if I have a complete rotation in 3 pi, I'm going to need half of that on either side, which is going to be 3 pi on 2 on that side, 3 pi on 2, negative 3 pi on 2 on the other side. So let's go 3 pi over 2, because I'm halving that for the right side, and negative 3 pi over 2 for the other side. That is where my asymptotes are going to be. We know that the tan graph, as long as I haven't done any translating, will be going through that origin. Now, because I don't have any other key points, really, for the tan graph, I should find out what is happening in the middle there, just to get a little bit of steepness happening here. So 3 pi on 2, what is half of 3 pi on 2? 3 pi on 4, correct. And let's do the negative 3 pi over 4 over here. And if I were to work out what that equals by subbing it in, so over here I'm going to say when x equals 3 pi over 4, if I sub that into my equation, I get y equals 2 tan, and I have a third times 3 pi over 4. What happens if I do that? I just get pi over 4 because the 3's cancel out. Do you need me to write that down, or is it okay to go pi over 4? It's okay? You got that? All right. Pi over 4. Do you remember what that is in degrees? 45. Okay, because remember, a little quick reminder here, you sub in that the pi is 180, so it's 180 divided by 4, which is 45 degrees. Tan of 45 degrees is an exact value on your triangles. What is it? Oh, 1. So that whole tan of pi over 4 is just equal to 1, and that gives me y is equal to 2. It's actually a very nice point. So we can put that on here. So let's put a 2 here, like that. And we don't need to sub it in again because we know this is symmetrical. The negative pi, 3 pi over 4, will be down at negative 2 down here. Please make sure that this is a curve though, it's not a line. Tan curve coming through there like that. All right, next. Question 2. All right, A, we have y equals cos bracket x plus pi over 6. So I've just reduced this down to one change because it's a phase change, and that's often the trickier one. So I just wanted to do one of these with no other changes, just the phase. So it is an x plus pi over 6. So if you think of that being equal to 0, you move the pi over 6 across the other side, and it would be negative pi over 6, or pi over 6 to the left. Yes? With me? All right. So that means I'm shifting to the left pi over 6. That is also known as a phase of pi over 6. Okay, so the cos graph, let me draw a quick one up here for you. Starts up here, does that. So that's 2 pi there. That's pi in the middle and 0. Okay, I'm not changing the amplitude. I am not changing the period. I am just changing the phase by pi over 6. Okay, so that means I need to change my x-axis scale to be pi out of 6s so that I can move everything across. All right, so you will need quite a few little increments here. Starting at 0, I'm going to be going up by pi over 6. So pi over 6 plus another pi over 6 makes 2 pi over 6, which is pi over 3. Plus another pi over 6 is 3 pi over 6, which is pi over 2. You get good at simplifying fractions doing this. So that's 3 pi over 6. Then 4 pi over 6 is 2 pi over 3. 1, 2, 3, 4, then 5 pi over 6. And then 6 pi over 6 is just pi. You see what I'm doing by counting up by 6? It makes it hard because I'm simplifying fractions at the same time. Yeah. All right, keep going. Yeah. Next one is 7 pi over 6. 8 pi over 6 is going to be 4 pi over 3. 9 pi over 6, well that simplifies too. 3 pi over 2. 10 pi, you should. Yeah, I guess you don't have to. What was I up to? What's my spot? 9, 10. 10 pi over 6 is 5 pi over 3. 11 doesn't simplify, so that's good. And then 12, extend my line a little bit. 12 pi over 6 is finally at 2 pi. Now it's 360 degrees, correct. Now I am moving this one space to the left, which means I need a negative pi over 6 here as well. All right, my amplitude is going to be 1 and negative 1 because I haven't changed that. Okay, now normally my cos graph starts here. I'm moving it pi over 6 to the left, so I'm just going to go, whoop, move it to there. Okay, move it to here. My next point is on my little red graph at the top here. At pi over 2, that's where it goes through 0. Pi over 2 is here, and I need to move it pi over 6, so one spot to the left. Do you see what I'm doing? Just moving everything one spot over to the left. So that's pi over 3. Then at pi, one spot to the left will be negative 1. At 3 pi over 2, which is here, one spot to the left is back at 0. And my 2 pi should be back to 1, but I move it one spot to the left, that'll be 11 pi over 6. So you can see how important it is to have all that scale drawn up so that you can just move everything across one spot. Then try to draw your curve nicely going through. Okay? Yeah? Okay, let's do it again. This phase stuff, the fun stuff. Now we're going to do a sine graph. So we have y equals sine x, x in brackets minus 2 pi over 3. So which direction am I moving at this time?
Right.
Shift to the right, 2 pi over 3. That is known as a phase of minus 2 pi over 3. I'm only writing that part because they asked me to write that in the question. It's the shifting right part that I find helps you to draw it. Okay, so this time I'm going to have to go up in thirds. That denominator, okay, thirds. So let's change our scale on our x-axis. Yep, try to give yourself as much space as possible. Actually, alright, so pi over 3, so that's 1 pi over 3, 2 pi over 3, 3 pi over 3 is pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3 is 2 pi. I am moving 2 pi over 3 to the right, which means my sine graph, let me draw the little one just so we can use it as a reference. This is my normal sine, which goes through pi, 2 pi, pi over 2, and 3 pi over 2. It normally starts at 0, which means I have to move that point over here to 2 pi over 3. I'm moving it to the right. That's my starting point. Then my next point is normally at pi over 2, so up here, but I have to move that over 2 pi over 3 places, which will take that to
7 pi over 6.
Yeah, I need to halve my scale again, don't I?
Yeah, freak man.
Let's go through, because it's 4 pi, it's 7 pi over 6. So let's do pi over 6 in here. 2 pi over 6, 3 pi over 6. Yep. 1, 2, 3 pi over 6 is pi over 2. 3 pi over 6. Losing my train of thought. 1, 2, 3, 4. Now I need 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. That would be 9 pi over 6, which is 3 pi over 2. Okay, so I was starting at pi over 2, and I'm moving it 2 pi over 3 to the right. So 1, 2 spots over here makes the 7 pi over 6. And I need an amplitude of 1, which I haven't drawn on here yet. Seven pi over 6. You can grab a calculator if you want. What I've done is I said this original point was at pi over 2, and I need to add 2 pi over 3 to that, which was my 6. That's where my 6 came in, because that's a denominator of 6, which is how we got 7 pi over 6. Okay, because I got a common denominator, which is 6. It's 3 pi plus 4 pi over 2, which makes 7 pi over 6. Okay? Then, let's do it again. We need to move the next one over. We're at pi, we're at 0. I need to move pi. From pi, I have to add on 2 pi over 3. Don't worry about the pi part. If you use your calculator, you're just going 1 plus 2/3, which is 5 pi over 3. So it's going to move to here. Now, I would keep going. I've only done half. Yeah. I've only done half of my period of that sine curve. But instead of keeping going forwards it's actually better to go backwards and make sure that your graph goes through the y-axis. Okay, so now we're going to go back the other way. From the 2 pi over 3, I need to come back pi over 2 spots. Where is that going to put it? Pi over 6, excellent. So down here at pi over 6 is where it's going to be at -1. Yep, where is my intercept over here? So it's started off at 0.
Negative pi over 3.
Very good. So let's do a pi over 6 there and negative pi over 3. So it's going to come up through there. So because I've got them all set up in 6, it's every 2 spaces. Can you see that every 2 spaces? So from here, it was 1, 2 spaces to that intercept. 1, oh, wait, 1, 2, 3. Sorry, 3 spaces. 3 spaces. 1, 2, 3 spaces to there. 1, 2, 3. 1, 2, 3. Every third space. All right, let's go again. Told you the phase stuff was the fun stuff. Yeah. Okay, let's do one with 10. Guys, if we have y equals tan bracket x plus pi over 4, how are we moving this graph?
To the left.
Yes? Yes. Shift left pi over 4. The halves and the over 4 is way easier. It's the thirds and the 6 I think that are more complicated. Okay, so that is a phase. No, it's they do the opposite direction. Pi over 4.
Fraction do like more over 4 over 8 because fractions are over 8.
Over 4.
Yeah. Over 4. You can cut pizza into quarters.
Oh, okay.
If you want to make slashes, then 1/8 is the most practical.
All right, so let's think about this. My original graph. My original tan graph goes through the origin. I need to move it pi over 4 to the left, so it's going to go through minus pi over 4.
What should our graph scale be like that, or should we do it more ideal?
Just give yourself some, it's tan, so it's going to be in the middle. Okay? Where are my asymptotes going to be? Normally my asymptotes are at pi over 2 and minus pi over 2, so from each of those, subtract pi over 4.
Minus 5 pi over 4 and 3 times 4.
What was your first one?
Minus 5 pi over 4.
Isn't it 3 pi on 4? Minus 3 pi on 4? So it's normally between pi over 2, let me just do a check. Might be right. Minus pi over 2, and I want to subtract a pi over 4. Common denominator will be 4 here and 2 there, so that makes a minus 3 pi over 4. Okay, so it was 3 pi over 4. So minus 3 over 4, let's go up by quarters. So there is going to be 2 quarters, otherwise known as pi over 2, and there's my minus 3 over 4, which is where my asymptote is going to be. Okay, then my other asymptote, which is normally at pi over 2, and I'm subtracting off my pi over 4. Where is it? It's at pi over 4. So vertical asymptote there. Pi over 4. To find my y-intercept, just for fun, sub in when x equals 0, because tan graph we don't have anything else otherwise. So when x equals 0, we're going to have y equals tan of 0 plus pi over 4, and we've already talked about pi over 4 being 45 degrees. which is equal to 1. So that intercept in here is going to be going through 1. And my tan graph will be coming up like that and symmetrically down the other way. Okay, so I hope you're getting the idea. It is time consuming where you've got to go, where are those things moving to? But if you do it systematically, it works. All right, one more, question 3. There's a question 4? Oh, there is a question 4, you're right, sorry. Missed one.
This was us, I couldn't do it at home if we can't finish it.
We gotta go 30 minutes.
All right, let's go. Okay, question 4. This has got lots of changes. Let's start with the period of the graph. So the period of a cos graph is normally 2 pi. What do I need to divide mine by? The 2, because it's the number in front of the x. So the period of this graph is going to be pi. That is a phase difference. How do I work out my phase difference? I take my 2x plus pi over 2, and I'm going to move the pi over 2 because it's equal to 0, move it across the other side, so minus pi over 2, and then x divide by 2 to both sides, it would be minus pi over 4. So what that means is that I'm moving pi over 4 to the left. The amplitude of my graph is 4. It's the number in front of the cos. And I also have that minus 3 on the end, which means what? Yes, moved down 3. All right, I'm going to try and do all of that in one go.
That's a lot.
It is a lot. Okay, let me warn you. You are going to need to go down to -7 on your y-axis. Guys, if we need to be fast, I need you to stop talking so we can do it. All right, I'm going to just do the pi over 4 as my scale. And I'm going to have to go onto the negative side here as well. For a start, might be good to have a think about where the original graph is. So I'm going to put a few numbers here on my y-axis. Okay, so normally, oh, sorry, just taking some time to write some numbers on here. Normally, the cos graph starts at 1, and by pi, I've only done half of what we normally go to 2 pi, I've only done halfway. It's at -1, so it intersects there. That is the first part of the normal cos graph. So let's have a think. If I am going to move this graph pi over 4 to the left, I am going to then times it by 4 for the amplitude. Okay, so let's do this. I'm going to change colour. Yellow. So I'm here at 1. I'm going to move 1 pi over 4 to the left. I am then going to times that by 4. So 1, 2, 3, 4. And then, no, so 4, 1, 2, 3. I'll be there at 4. And then I want to subtract 3 because the whole graph has been moved down 3. And I end up here. You should have paid attention. All right, let me do it again. Quickly. Because I'm doing a different color for the new graph. The red graph is the original one. I'm moving it to the yellow. I'll do it for the second point. Shh. Let's go over to the, actually better idea. The whole period of this graph is pi. So where is it going to end?
3 pi over 4.
3 pi over 4. So if I found the first point, it's going to finish there at the same point at the other end. Where is the middle of those 2 points? Pi over 4, which will be the lowest point. Where is that lowest point going to be?
-7.
Is that because I told you that?
Wait, what?
Alright, it was at -1. -1, you're timesing that by 4 is 4, but then you've got to
Take 3.
-4 and then take 3 makes -7. Yes? Then, in between there, the zeros, 0 times 4 is still 0, -3 is -3. So where the zeros are now going to be at -3. And the curve will come down like that.
Miss, I don't understand why the last point is up there. The same as the other side.
Yeah, because the cos graph. So I found the first point and the last point, and then I kind of found in the middle. All right, let's quickly squeeze in this last question. I don't think this one will be as long. Question 4. Sketch y equals sine x and y equals x squared minus 1 on the same graph. That is a very nice sine graph with no changes. So let's draw because I have to draw a parabola on there as well, I'm going to use normal numbers on my x-axis. So 1, 2, 3, 4, and -1, -2, -3, -4. And I'm going to do I'm going to go up by 3 on my y-axis and down by 3 as well. Okay, now because I'm sketching sine, the sine graph, pi is just past the 3 here, so there's pi. Half of pi is about 1.57, it's about there. So that's my pi over 2. Negative pi will be just past the -3, and negative pi over 2 will be at -1.57. So to draw my sine graph, it starts at the origin. At pi over 2, it's at 1, and at pi, it's back to 0 again. If I draw the other side of it, at negative pi on 2, I'm down at -1, and at pi, I'm at 0. Now, I know I don't normally draw that part of the sine graph, but I'm going to be intersecting this with a parabola, and I'm going to need to see that negative side, because the parabola is going to be on that side of my Cartesian plane. The parabola, y equals x squared take away 1, has a y-intercept of -1. The intercepts on the x-axis, if you do a quick factorize, it's x minus 1, x plus 1. So null factor is at 1 and -1. And then we can draw our parabola coming up through there. Okay, so we have sketched both the graphs. Then in part B, it says to use part A to find the approximate solutions to sine x equals x squared minus 1. They are the two graphs that we have drawn, which means the solutions are the points of intersection. So how many points of intersection do I have?
2.
So 2 solutions. And approximately, as best we can, what are they? Now, our graph is not perfect. So this one in here, I don't know, x equals, I'm going to put minus 0.6, minus 0.7, yep, okay, it's all in the ballpark. And the other one on this side is just past the 1, but before the pi on 2, 1 point what?
1.1.
1.1, I would say 1, I said 1.4. 1.3 maybe, 1.3. Okay, as long as it looks reasonable from your graph. You could obviously go to Desmos if you wanted it more accurately. You're not going to be required to do it more accurately. Usually you just want how many solutions there are. Ooh.